Hello, in this video we're going to look at a couple problems with modeling quadratics. So the first one says if 100 meters of fencing will be used to fence a rectangular region, then what dimensions for the rectangle will maximize the area of the region? And then also what is the maximum area? So first let's identify a formula for what we're maximizing. And so that's area. And so area is length times width. Now, if we think about a maximize, then what the strategy we're going to use for this is look for a quadratic equation where we can find the vertex, because that will give us a maximum value. So let's see if we can set up this picture. And this is kind of tricky to set up. We have a rectangle. It's not a great rectangle, but we have 100 meters of fencing. Okay, so let's play this out with an example maybe. So if this is 10, then this would have to be 10. Okay, so then I have 80 meters left. So I divide that by 2, and then this would be 40 and 40. Okay, so let's see if we can do that with letters. So if this is x and this is x, and how much do I have left? Well, I have 100 minus my x's, so minus 2x. But I have to use that for both sides, so I divide that by 2. And that gives me my length and my width. So then my area is x times 100 minus 2x all over 2. Okay, so if I maximize this, now you think, well, that's not even a quadratic equation. What is that? Well, let's simplify it a little bit. I can divide both of these by 2, 100 and 2x that is, so that becomes just 50 minus x. And then I can distribute, and so that becomes, I'm going to make it minus x squared plus 50x. So I switched the order but distributed the x. So now I have an equation that I can maximize for the area to find the area. And when we look for a maximum, it's quadratic. Our maximum is just the vertex. Well, this is in standard form, so our vertex is negative b over 2a. So that's negative 50 over 2 times, and then a is negative 1. And so our maximum value occurs when x is 25. Okay, so what's that mean for my rectangle? Well, that means this would be 25. Let's just draw a new rectangle. So this is 25, and this is 25. And then you might be able to just do this in your head because we only have 100 meters, and so that's a pretty round number. We only have 50 left, so it turns out my maximum area is a square. So what dimensions would be 25 by 25? And those are both feet, or those are both meters rather. And then my area is 25 squared, which is 625. I should have known that. You could also find the maximum area by plugging in the x into this equation. Okay, another common application for quadratics is a projectile, so something flying through the air. And once again, if you think, you can kind of think about like this is a cannonball, this cannonball flying through the air, then this vertex up here is going to give you the maximum height in this case because we're modeling height. And so the maximum height is the y value. And when it occurs is the how long it takes to get to that maximum height is the x value. So the x value is time, the y value is the maximum height. In this case, we want to find the vertex, and then what does the vertex mean? So we've kind of already talked about this, but the vertex will give you the maximum height of the cannonball, and then when that height occurs. So we want to do x equals negative b over 2a again, because it's in standard form. So it's negative 10 over 2 times negative 0.01. And you can just type that in your calculator. 0.01. You could probably simplify it, but it's 500. and I believe it was in feet. Do we even give? Yeah, in feet. So the x is 500 feet. So wait, hold on. X is. Oh no, I said time earlier. This is modeling with feet. So x is 500 feet. Um, then my height, I need to plug in to the function to find the maximum height. So it's going to take 500 horizontal feet for the cannonball to get to its highest point, and then my maximum height we get by plugging in 500. And so you can type this whole thing in. Let's see if I can type this in correctly. 0.1 times 500 squared, and then plus 5,000, or 10 times 500, and then plus 5. So I got 2,505 feet, and this would be the high. So if you have a word problem with quadratics, a lot of times you either want to look at the vertex or the y-intercept. Almost always the vertex represents the maximum in the given situation. The y value is actually the maximum value, and the x value is when that occurs.